All right, guys. Our meeting has ended, and the only one who actually came today was Chris, and he was working ahead and had questions about what you're doing for tomorrow. So I didn't record that. But one thing that did come up that I thought would be worth covering with you guys is talking about outliers and also talking about comparing data a little bit, two sets of data a little bit more. You have to do this tomorrow in one of your problems. So I figured I'd show you a little bit now. You've seen a little bit of this already, but I just wanted to go over it with you some more. Okay. So you can see here that if it'll let me, hang on, share my window. There we go. All right. So you can see here I have two sets of data, and if I am going to make some kind of a model, let's say I'm going to make a box plot out of this, out of both of these. I can actually make a box plot for both sets of data at the same time. Okay. I'm going to go ahead and make my number line, and you'll notice the highest it goes is 20, the lowest is 2. So I'm going to go ahead and count by twos. 2, here's 20. So we have 4, 6, 8, 10, 12, 14, 16, 18, and here's 20. So I'll erase that other one. So it's all nice and evenly spaced. Okay. All right. It says I'm recording. Okay. Sorry, I thought my camera stopped recording. So now I'm going to identify the 5-number summary and do the box plot for each one. So for the 5-number summary, I have a min, Q1, median, Q3, and a maximum. All right, so I'll do the red data first. So my min is 2, my max is 20. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data in each one, which means my median is going to be between the 7th and 8th, because half of 14 is 7. So I'm going to have 7 pieces of data on either side. So I have 1, 2, 3, 4, 5, 6, 7. So the median in this case is going to be between 9 and 12. All right, if I add 9 plus 12, I get 21. I got to divide that by 2, and that gives me 10.5. So that's my median for this bit of data. Okay. Now I'm going to look for Q1 on the left side. All right, and because I have an odd number of data points, I can see that, there's 7 here, so the 4th one is going to be my Q1. So Q1 is 7. And over here on the other side, we have 7 pieces of data as well. It looks like I have more, but that's just because these are 2-digit numbers, so it took me more space to write them in. So again, since there's 7, the Q3 is going to be the 4th piece of data, the 18 right there. Okay, so I am going to go ahead and draw my box plot, and I'm going to kind of draw it high here because I'm going to put the blue one near it. So there's my max at 20, my minimum at 2. Let me number some more of the values down here so make it easier to find. 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, so my Q3 Q3 is at 18. Okay, so that's going to be the right-hand side of the box. So I'm going to put a vertical line there. My Q1 is at 7. So here, right between 6 and 8 is 7. Okay, and then the median is 10.5. So here's 11. So here's 10.5 right here, 10.5. And now I just draw my whiskers on either side. I draw the box here. Okay, and there we have it. And you might, to look at this data, it's kind of an interesting distribution. It's not really skewed one way or the other. This whisker is longer, but this half of the box is spread out more. So that's going to kind of balance it out, and the mean will kind of end up being right around the median. So we would say we wouldn't necessarily call this symmetric. We're going to look at the histogram in a minute, so that might give us a little better picture even. But this is kind of symmetric. But let's compare it to our other set of data. Okay, I'm going to find the 5-number summary for the other set. The min is 3, the max is 20. Okay, the median, again, it's going to be between, since I still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data. The median is going to be between the 7th and 8th piece. So between 11 and 12 is 11.5. All right, so that's my median. And then the first quartile is going to be the 4th term of this bottom half of the data, these 7 items. Okay. And so, yeah, again, that was 9 for the first quartile. And then we have this top half of the data starting above the median. Okay. And again, since there are 7 items of data there, we are going to look at the 4th one because that's going to be right in the middle, 3 on either side. So that's 14 for our Q3. Okay. So now as we go to sketch this, we have 3 as our min. We have 20 as our max. We have the median at 11.5. So if that was 10.5, 11.5 is going to be kind of close to 12. So it's going to be a little bit further to the right as from our red one. And then we had 9. So that's going to be here is our Q1. And our Q3 is 14. Okay. So I finished drawing my box. And there's a couple of things I can see here, okay? While this red one was somewhat symmetrical, this one actually we see an even better symmetry in the distribution, okay? The other thing that we see is that that middle 50% is actually clustered really close together. Here, these numbers were kind of all over the place across the range from 2 to 20. But these values here, we only had a few down here. So our bottom 25% was, pretty spread out. And you can see that 3, 8, and 8. Our top 25% was kind of spread out. You can see that 16, 17, and 20. But this middle 50% between the 9 and the 14, you can see all those 10, 11, 12, 13. They're all crammed right in here, okay, from 9 to 14. So this is another way that we can compare these. We can see, hey, these were spread out a little more. These were a little more consistent, but we still had similar extremes. Now, one thing I would look at with this blue set of data is outliers, okay? Here, when you have such a spread out middle 50%, your whiskers were not very long, so you're not going to have any outliers. But if you look at this data, because of how small the middle 50% is distributed, how tight that range is, then you very likely could have some outliers. So I'm actually going to check that. And to review how to find these outliers, we were doing this on Monday. Remember, you take the IQR, and you multiply it by 1.5. So 1.5 times the IQR. Okay, well, the IQR here, the first quartile is 9, the third quartile is 14. So from here to here, the IQR is 5. Okay, so this is 1.5 times 5, and that actually gives us 7.5. All right, so if you recall, we were finding the fence on the left and on the right. Okay, on the left side, remember we use Q1, which is 9, and 9, we subtract the 1.5 times the IQR, which is 7.5, and here we get 1.5. So notice 1.5 is right here. So even though we kind of came close, we don't have any outliers on the left. Okay. On the right, remember we take the Q3. Q3 was 14, we said, and we're going to add 7.5. Okay, so that's 21.5. That's going to put us somewhere over here for the fence. And thankfully, we only went up to 20, so we actually don't have any outliers on that side either. Okay, so this one was kind of questionable. It was definitely worth testing, but because our fence is beyond either whisker, we do not have any outliers in this case. Okay, no outliers. Let me just comment on one thing too here real quick before we go any further. I want to make sure that you guys understand outliers are extreme values. So they're going to be the highest or lowest values. Some of you, when you were doing the assessment on Monday, I asked you about every value in the data set, and I had some of you saying like a number right in here was an outlier. Okay, and I think that some of you just weren't really understanding the concept of what an outlier is. It's going to be way beyond on the outside. So if you have any numbers that are between Q1 and Q3, they cannot possibly be outliers. All right. So say for the red data, even without calculating it, if I asked you if say 11 was an outlier, well, that's between 7 and 18, so that's definitely not an outlier. Here on the blue, if I asked you if 13 was an outlier, well, that's in the box. That cannot possibly be an outlier. So outliers have to be outside of the box. So keep in mind, if I ask you something like that, that should be a gimme question. You know, that should be one that you get really easily, because if it's inside the box, if it's between the quartiles, you know it's not going to be an outlier. Okay. Now, one other thing I want to do here, and I meant to copy this before I wrote all over it, but let me just do this real quick, and then I'll get rid of the stuff I don't want. It'll be faster than rewriting it all. Okay, so I'm going to copy that and come down here. All right. All right, let's paste that right there. Okay. And I'm going to actually erase the highlighting that I've got. This is a lot easier than rewriting all the numbers. Oh, lost a 9. Get that back. All right. So at this point, what I'm actually going to do is I want to talk to you about when you're asked to draw a histogram, and in particular when you're asked to do more than one histogram. Okay. So when you're given something like this, you're going to be asked to, or you might be asked to draw a histogram that summarizes two different sets of data. Okay. And the first thing that we would do here is we would go ahead and divide the data range up into manageable pieces. Okay. So actually, let me do this real quick. I'm going to change that to black so it doesn't blend in with our other data. Okay. So as I look, I'm going from up to 20, and it's spread out. I only have 14 pieces of data, so I'm going to go ahead and split it into divvying it up by 4s. Okay, so I'm going to make one go from 0 to 4. The next range is going to go from 5 to 8, and then from 9 to 12, and then 13 to 16, and then I'm going to go 17 to 20. Okay, you do want to use evenly divided. Each of these is 4 values. Okay, I guess technically this would be 1 to 4. We don't have any zeros anyway, so it doesn't matter. Okay, then also, so what I'm going to do here is I'm going to divide up the data into those regions as well. So the 1 to 4 range, I have that. And we can actually make a little table to help us organize our data. 5 to 8, 9 to 12, 13 to 16, 17 to 20. All right, so I'm making this table here for both sets of data. Okay, and this will help us as we go to draw our histogram. Okay, if we were doing a dot plot, we wouldn't bother with these ranges. A dot plot, you would put every different value 2 through 20 on here, and then you put dots. But for a histogram, we're actually going to divvy this up. So in the 1 to 4, or again, I put 0. In the 1 to 4 range, there are 2 from the red data. On the 5 to 8, there are 4. So 4 in that group. On the 9 to 12 range, there's only 2. Okay. So there's 2. On the 13 to 16 range, there's actually only 1. And then on the 17 to 20 range, we have 5. Okay. So we have 5 there in that grouping. Okay. So I'm going to do the same thing with my other one in the 1 to 4 range in blue. And then we have the 5 to 8 range. And then we have the 9 to 12 range. Oop, missed one. Okay. And then we have the 13 to 16 range. And then finally, we have the 17 to 20 range. Okay, so if we count up each of the ones in those ranges, there's 1, and then 2, and then 1, 2, 3, 4, 5, 6. 3 in that range, and 2 in that range. So the reason why we're doing this, notice the highest it goes is 6. So I'm going to put 6 up here. 1, 2, 3, 4, 5. If you have bigger numbers, you can count by twos or whatever. But I'm going to do the red one first. And you notice in each of these ranges, I'm only going to use up half the space. So there were 2 in the 1 to 4 range. Okay. There were 2 in that range. And then there were, in the 5 to 8, there were 4. Again, I'm only going to use half of that space. I'm not very good at coloring. There we go. We got the idea. And then there are 2 in the 9 to 12 range. Shorter one, easier to color. In the 13 to 16 range, there was only 1. And then in the 17 to 20, there were 5. Okay. All right, so now we're going to do the same thing with the blue right next to it. So in the first range, there's only 1. 5 to 8, there were 2. Okay. And then in the 9 to 12, there were 6. Okay. In the 13 to 16, there were 3. So that's up to there. I made this range a little bit wide. And then finally in the 1720, there were 2. Okay. Now, what you can see here is that if you look at these, you can do it in 2 different colors if you have it, or like one of them you could just make rectangles, the other one you can kind of box in. However it makes sense to you. Let me see if I can do this real quick. There we go. But you can see the red one, kind of the way we saw it on the box plot. There were a lot that you had like a lot down here and then a lot up here, and it was kind of inconsistent. That's why we said it wasn't really that great of a symmetric distribution. This one doesn't really have a specific shape to the distribution, okay? But the blue one, we actually said was a better distribution, a better example of a symmetric. And you can actually see that if you kind of trace these and make a curve, all right, that's relatively symmetrical. But notice by doing both histograms on the same thing, you can kind of get a better sense of how they compare to each other. All right. The red one didn't have a whole lot in the middle, but they had a lot down here and a lot down here. But the blue one, most was in the middle, and then you had these tails on both sides. So that's where you get the symmetry from. Okay. So I wanted to point that out to you guys. I hope that's helpful. And I hope you guys can get this pretty well and be all ready for our quiz on Friday over skew and outliers. All right. Have a great day.